Okay, so this is something I found out right quick. Victor Glushkov made a memoir recording, audio recording right before he passed away. This is a this analysis is based on a transcription of that. So definitely want to thank the folks that put that up on the internet. And I haven't I haven't heard this yet, and we'll just dig in. We'll see what AI had to say about Glushkov's memoirs. It's bound to be interesting. It's about it's a little over 42 minutes, so let's find out let's find out what AI thinks about Glushkov's last words. And this is Military Industrial Museum. Make sure you like and subscribe. I'm trying to get some more subscribers, and not real sure how to get a whole lot, but maybe bits and pieces here and there, I guess.
Imagine a brilliant mind facing the end of their life, dedicating their final moments to distill decades of groundbreaking work into a lasting legacy. That's exactly where we're going today.
Yeah, it's quite a powerful image.
This deep dive takes us into the extraordinary memoirs of Viktor Glushkov, a truly pivotal figure in Soviet cybernetics and computing. And our source material isn't, typical.
Not at all. It comes from these incredibly lucid voice recordings made by his daughter Olga during the last 9 days before he passed away in January 1982.
Wow, the last 9 days.
Exactly. And what's truly remarkable about these recordings is that they aren't just like personal anecdotes, they're a remarkably coherent and forward looking summary of his vast team's achievements, his core conclusions, and a detailed articulation of future tasks.
Sort of like his last will for science.
That's what many who knew him called it, yeah. Publishers, recognizing their monumental significance, gave them titles like Confession, The Last Deed of a Scientist, or For Those Who Stay. Each title kind of captures his incredible effort to summarize a lifetime of work while battling a fatal illness.
His scientific life was, well, in many ways, a daily feat that went far beyond his personal battle. It was a collective action, really, inspiring thousands across the Soviet Union.
Absolutely.
And here's the kicker: many of his ideas remain as relevant today as they were when he first spoke them. His global recognition was undeniable. I mean, he was invited to write the Cybernetics article for the British Encyclopedia.
He was, yeah. Quite an honor.
So, our mission in this deep dive is to bring you Glushkov's journey, his visionary management principles, his audacious technical innovations, the intense battles he fought against bureaucracy and skepticism,
and his enduring insights into the future of computing and artificial intelligence. All of this directly from his final profound reflections.
It's genuinely moving to consider that these incredibly lucid insights came from his final days. Can you tell us more about the specific circumstances of these recordings? What makes them such a rare document?
Absolutely. So, as you said, these voice recordings were made in a hospital early 1982, specifically during those last 9 days. His daughter, Olga, meticulously made them.
Right.
And we really owe a debt of gratitude to his other daughter, Vera, and granddaughter, Victoria, for allowing their translation and publication. Because while parts of these memoirs were published before in Russian,
Okay.
like in Boris Malinovsky's History of Computing Technologies and Personalities, this particular transcribed work is seeing the light in English for the very first time.
So, this gives you an unparalleled lens into the mind of a scientist reflecting on his life's work, looking to the future, knowing his time was short.
Exactly. It's unique.
To really grasp the scale of Glushkov's vision, we have to go back. How did he lay the groundwork for this massive scientific empire? What was the initial landscape like when he arrived in Kiev?
Okay, so we begin in 1955. Glushkov took a year-long sabbatical from the Forest Engineering Institute in Sverdlovsk. He needed to complete his doctorate at Moscow University, which he successfully defended in December 55.
Right.
During this time, he met academician Boris V. Gendenko, who was then a key figure in the Ukrainian Academy of Sciences. And this meeting was pivotal
Why pivotal?
Because in 1955, a decision had been made to establish these prestigious academic computing centers in various Soviet republics, including Ukraine, and Gnedenko was tasked with this enormous undertaking.
Okay, so Gnedenko had the job, but what about the resources? Starting something like that from scratch sounds incredibly challenging.
Sparse would be an understatement, seriously.
Yeah.
They transferred equipment from the former Lebedev laboratory.
Ah, the MESM guys?
Yeah, the small electronic calculating machine, one of the earliest Soviet computers. But the lab they inherited consisted of, like, at most 40 people.
Wow.
Only 4 candidates of sciences. That's kind of like a PhD in the West. No full doctors of science, which is a higher degree, and hardly any young specialists.
So a tiny team.
Very. When Glushkov first visited Kiev in March 1956 to pick personnel, he famously insisted on bringing in A.A. Lidichevsky, even though the Gnedenko had reservations.
And that paid off.
Oh, brilliantly. Many of these early recruits became leading employees of the Future Institute. Lidichevsky was crucial.
So, with such limited resources and a small team, what were the immediate challenges, the first projects, and how did Glushkov's unique approach start showing up right away?
Well, the lab initially focused on 4 topics: a specialized machine for linear equations, the Kiev Universal Machine, and 2 secret projects.
Yeah.
But Glushkov, right from the outset, was driven to, as he put it, industrialize production. So he immediately went looking for external financing.
Smart. Outside the academy.
Exactly. He secured Dubna, the Joint Institute for Nuclear Research, as a customer for a second PEEV machine. This was a masterstroke.
Why was that so important?
It resolved critical financing and supply issues that the Academy of Sciences just couldn't handle on its own. Gnedenko, to his credit, organized Glushkov's work well, gave him 3 days a week just to study the subject and get onboarded.
Okay, gave him some breathing room.
Yeah, while a temporary supervisor covered his duties. Gnedenko also brought in V.S. Korylyuk and E.L. Yushchenko, boosting the number of candidates of sciences to 6. So, small steps, but crucial ones.
It sounds like he wasn't just building a lab, but a whole ecosystem, really. What about the physical space for all this?
Indeed. The computing center on Bolshaya Kitevskaya Street was under construction. Initially, it was planned for just 3 machines, but it had 3 large halls, which already hinted at much bigger plans.
Foresight, even in the architecture.
Right. The initial estimate of 400 workstations, way underestimated. This period also marked a personal breakthrough for Glushkov. He realized early computer designs were based purely on engineering intuition.
Just kind of winging it.
Pretty much. He actually figured out how the MESM worked entirely on his own, which, given the lack of clear documentation, was a huge undertaking.
Wow.
And from this, he declared his big decision: turn machine design from an art into a science. He set up a seminar where they rigorously analyzed how machines were made, developed formal theory.
So structure instead of just guesswork?
Exactly. He said they could immediately see what works and what doesn't. Interestingly, he found Klein's automaton concept more elegant and logically clear than Turing's, which he felt was unnecessarily complicated for their practical design goals.
That's a huge mindset shift, moving from intuition to a scientific foundation. It obviously paid off.
It did. On December 15th, 1957, the Computing Center of the Academy of Sciences of the Ukrainian Republic was formally established. About 120 employees and postgrads by then.
Including his first postgraduates, you mentioned.
Yes, A.A. Stodny and V.P. Durkak. He chose the academy over the university, partly because of an uninspiring chat with the dean at Kiev University. His appointment needed approval from G.N. Savin, the vice president.
And Savin had doubts.
He did, yeah. Doubted Glushkov could manage hundreds, given his smaller department back in the Urals. But the United Party Committee and the Science Department of the Central Committee were a massive help construction, supplies, hiring, even getting residence permits. They provided crucial support.
Okay, so from these formative years, Glushkov developed these key organizational principles for managing large teams, right? Which he credited with their success.
He did. He consistently applied them. One of his core beliefs was the unity of theory and practice. Now, this principle wasn't new, but Glushkov profoundly refined it.
How so?
He stated that science, especially young science, should not build theories that do not have practical applications. Fair enough.
Okay, standard stuff.
But here's the crucial addition. One should not start practical work, no matter how important it may seem, if it is not preceded by theoretical comprehension.
Ah, so theory first, always. That's the subtle but profound shift. Why was that so revolutionary?
Because it forced a fundamental rethink. Instead of just building one-off custom solutions, you had to build a theoretical base first. This, he believed, ensured incredible versatility. His words, potentially covering 500 applications instead of one.
Wow. Can you give an example?
Sure. Instead of developing custom solutions for 8 specific customer orders for modeling discrete systems, Glushkov told TP Marjanovich's team, no, create SLNG, a universal language for modeling these systems.
A platform approach.
Exactly. Then he educated the customers, showed them how this universal solution actually met their real needs better. It allowed for broad fundamental research with massive application potential, a masterclass in foresight and scalability we still, aim for today.
So build foundational tools, not just solve immediate problems. What other core principles did he apply?
Another key one was the unity of long range and short range goals. This dictates that one should not undertake any small individual works if one cannot see the continuation of these works in the future.
Don't start dead end projects.
Right. And conversely, long term research should only be undertaken if it can be broken down into stages, with each step promising a self-sufficient scientific and practical significance.
That's incredibly strategic, especially for something as complex as computer science. Break it down into achievable, useful chunks.
Precise.
Did this phased approach apply to something like AI or robotics?
Absolutely. This staged approach guided his whole intellectualization of machines program. It led to the MIR1 and MIR2 machines, and then the future work on automating proofs. Same idea for robots. Ensure practical utility at each step. Solve vision and hearing, for instance, before getting bogged down in intricate finger movement.
He also championed decentralized responsibility. What did that look like in practice, especially, in a top-down system like the Soviet Union?
Well, Glushkov advocated for allocating clear areas of responsibility to managers and then minimizing direct interference, even if subordinates seemed to be doing things wrong.
Really? He wouldn't step in.
Not directly on the decision, usually. He'd focus on integral indicators, the overall outcomes. There's a great example, apartment allocation, highly contentious issue, right?
Always.
So when complaints arose about V.S. Mislevich's decisions on who got apartments, Glushkov refused to overturn them.
Why not, if they were unfair?
His reasoning was fascinating. He said a senior manager canceling a subordinate's hours of work in 5 minutes would fundamentally undermine their leadership. No one would take responsibility seriously again.
Makes sense. So what did he do?
He used those complaint conversations to identify root causes, to address the overall style of work, the underlying principles, and improve the system itself. He was critical of multi-stage hierarchies where middle managers often got bogged down, struggled to delegate.
Holding on to power, maybe?
Exactly. Issues like housing, often seen as a source of real power, were held onto tightly hindering efficient management.
So rather than micromanaging, he focused on setting up effective systems. Did he ever formalize that for something like space distribution?
He did. For that persistent issue, he developed a precise procedure. A technical worker managed the files, a chief engineer set the technical standards for space, and priorities like from socialistic competition, results automatically determined allocation.
Taking the personal bias out of it.
Right. And to monitor usage. Probability theory and random sampling. Commissions would randomly check rooms. If you used your space poorly, you'd get less next time.
Clever. Accountability built in.
The core principle was a deputy director was penalized for their decisions or for poor personnel selection and training in their area, not for every specific slip up by a subordinate they couldn't directly control. Accountability at the right level.
Building on that idea of nurturing leadership, attracting the right talent must have been critical, especially early on. How did he manage that?
Talent was absolutely paramount, and they got a huge boost. In an almost unheard of move, the United Party Committee made an unprecedented decision to let the Institute fully control a residential building nearby.
Their own apartment block.
Yeah, II-3 Bolshaya Kidovskaya Street. This was practically unheard of in the academy. Usually institutes got just a few flats per building. It was a massive help in attracting and retaining top staff.
Okay, that makes sense. Which brings us to a truly remarkable story, the Dnipro breakthrough between 1959 and 61. What was the challenge they were trying to solve here?
Right, so the challenge back then was that traditional automation relied on these continuous analog devices. You needed separate, limited machines for each specific process, and they were only really good for simple differential equations.
Very rigid.
Very. So Glushkov's vision, which he presented at a big conference in Kiev in 1959, was to create a universal control machine.
And how was that received?
With hostility, apparently. From established automators, even from computing specialists, they just imagined these impractically huge, unreliable lamp-based machines. It was a bold, almost controversial idea.
So, how did they overcome that skepticism and build something revolutionary?
The solution, the key, was B. N. Malinovsky's early work on semiconductor elements in the USSR. That proved crucial. Glushkov's team just boldly pursued the project, despite what he called efficient for most control processes.
Okay.
And crucially, it had to incorporate a universal remote telecontrol unit, or RTU. Think of it as a set of analog to digital and digital to analog converters, the interface connecting the machine to the actual factory floor.
Malinowski was chief designer, Glushkov the scientific supervisor, and they did this in just 2 years, June 59 to July 61. Glushkov called it a world record, especially since Ukraine wasn't supposed to be building computers at all. How on earth did they manage that speed?
Glushkov's strategy was pure genius. He paralleled all the stages: development, training future users, and preparing production all at the same time.
Wow, okay. How?
He immediately got powerful political figures involved, Olga Veshchenko and V. Podgorny, got decrees issued mandating the Kiev Radio Prebor plant to help develop and manufacture it, and greenlighting the construction of the VUM plant, with staff trained at Radio Prebor.
He built the factory while designing the machine.
Essentially, yes.
Yeah.
And Glushkov personally lectured the Radio Prebor design engineers on machine design, making sure they were totally aligned with the vision.
That's incredible foresight, building the demand and the production capacity simultaneously. What about testing and early applications? How did they prove it worked?
They picked 4 initial industrial sites: a shipyard, a metallurgical plant, a chemical plant, a soda plant, later an ammonium nitrate plant too. They got these places ready for computer control.
Okay.
The initial movable RTU was intentionally designed as just an assistant to the human operator, not a full replacement. That was smart acknowledged human factors and the high cost of errors, like steel freezing in a converter if the computer messed up.
Good point. And debugging.
They pioneered remote debugging. Data from the mobile RTUs was sent via telegraph. Can you imagine? Back to the Kiev machine at the computing center.
Which was already running by then.
Right, since 58. This let them debug the software for the Computer Dnipro machine in parallel, while also tackling the basic control algorithm challenges.
And the results. You mentioned they were impressive.
They really were. At the steel converter, they cut down the number of blows, reduced rejects, and boosted productivity by at least 10%. And this was with relatively simple algorithms and, frankly, imperfect sensors.
Wow. Even with basic tech, the impact was huge.
Soda output up 4%, metallurgy 10-12%. It was tangible. They even set up competitions. Plant directors watched as any operator using the machine got much better results than their very best human dispatchers working alone.
That must have convinced them.
Absolutely. That success immediately made the plant directors demand more. Glushkov, ever the strategist, pointed them straight to the Radio Prebor plant, which was already gearing up for serial production. He created the market even before the prototype was ready.
Amazing. And the production itself.
Because Dnipro was developed jointly between the Institute and the plant's engineers, no us versus them, it saved huge amounts of time, at least 2 development stages, because it was customized for the plant's tech from the start.
Seamless integration.
Yeah. And the director of Radio Prebor, Matt Vazinovich, took a massive gamble. He courageously started building 10 copies before the prototype even passed the state commission tests.
Risky.
Hugely. But Dnipro delivered. It passed tests perfectly, worked flawlessly in a dusty, hot, plus 50 degrees factory room, and was rugged enough to be chucked on a truck for military exercises. Compact, reliable, truly built for industry.
A genuine triumph of engineering and strategy. What came next in machine development after Dnipro?
Well, in 1961, they started on the MIR-1 machine. The goal here was different: create a unified elementary-based semiconductor elements for all their future mini-machines, a first in Soviet practice.
Standardizing components.
Exactly. This effort led to the formation of their own design bureau, which in 1963 officially became the Special Design Bureau of Mathematical Machines and Systems, the SDB-MMS. And these common elements they designed were so good, they were used for a decade across the Ministry of Instrumentation and Automation.
So they weren't just building machines, they were building the building blocks. Did they catch up with the West at this point?
It was close. Glushkov noted that while Americans had started working on similar multi-purpose control semiconductor machines earlier, they actually put them into production in June 1961, which was simultaneously with his team finishing Dnipro. He saw this as one of the moments when we managed to reduce the existing gap to 0.
Reducing the gap to 0? That's a massive achievement. How widely adopted was the Dnipro itself?
The Dnipro was the first Soviet semiconductor machine to go into mass production, and it held a record for longevity, produced for 10 years when 5 or 6 was typical.
Still in use decades later.
Yeah, amazingly. It was still running the big screen display at the Mission Control Center for the Apollo-Soyuz joint spaceflight in 74-75, and it was exported to many socialist countries.
Wow.
The Dnipro development really laid the foundation for that VUM plant constructed during this period. The MIR machine was also developed jointly with VUM, but recognizing they needed an independent design base, the STB MMS was formally established by decree in 1963, gave them more autonomy.
So, behind all this technical success and rapid expansion, there were also significant battles, right? Bureaucratic struggles. The formation of the Institute of Cybernetics itself in 57 wasn't smooth sailing. You mentioned friction with the Denko.
Yeah, despite Didenko's initial role in bringing Glushkov to Kiev, relations became strained during the Institute's formation.
What was the main issue?
The primary cause was intense competition for highly qualified specialists. It was fierce back then. Glushkov believed in fair competition. Lay out your trump cards openly, let the specialists choose. But disputes also flared up over shared property, even things like passenger cars. Glushkov's institute, being on the outskirts and needing to transport classified documents, argued they needed them more. Petty stuff, but symptomatic.
And there was a particular individual, Shkabara, who Glushkov said played a nasty role.
Yes, Shabara, a researcher from Lebedev's original team. Glushkov was blunt. She consistently played people off against each other. He also found her weak as a researcher.
Weak how?
Well, he cited her belief that AI could be solved with simple 3-digit logic, just yes, no, maybe, which, sounds incredibly simplistic for the complex, nuanced problems AI involves. It lacked the probabilistic thinking Glushkov was pushing for.
Lacked depth.
Right. And according to Glushkov, she lacked integrity too. She'd co-authored an anti-cybernetics article with Lebedev when the field was persecuted,
Oh, wow.
only to become a zealous supporter later when it became accepted. Glushkov made removing her one of his first priorities to improve the team's atmosphere.
So it wasn't just personality, it was about the scientific vision and, integrity.
Exactly. To be fair, Shkabara did later find N. Emisov, the famous cardiac surgeon, and helped him start a biological cybernetics department at the Institute of Mathematics, where she ended up.
Okay. What about Gnedenko?
Gnedenko's own position at the Institute of Mathematics weakened. His deputies started pushing to remove him as director. It got messy.
And then Gnedenko and Shkabara launched this public campaign against Glushkov Center, claiming it was just a computing center and they needed a new Institute of Cybernetics. That sounds like a direct attack.
Oh, it absolutely was.
Yeah.
A direct attempt to basically downgrade Glushkov's institute to a mere calculating station and poach its best people.
How did Glushkov handle that?
His team responded calmly, arguing that an Institute of Cybernetics already existed and just needed strengthening. Crucially, the big guns, the Science Department of the Central Committee and the United Party Committee, stepped in and prevented the Institute's destruction.
So the political backing was essential.
Absolutely. In February 1962, the Computing Center was officially transformed and renamed the Institute of Cybernetics. Initially, it still had with the Computing Center in brackets, acknowledging its origins.
What happened to Gnedenko and Shkabara after that?
Didenko resigned, moved to Moscow. Shkabar moved to the Institute of Physiology, apparently with limited success. Glushkov did note, a bit pointedly, that they later downplayed his role in creating the key of machine in their writings.
Interesting. Were there other personnel changes to sort of solidify the team?
Yes. Glushkov also had to, in his words, urgently kick out 2 more individuals, Pensuk and Yarosh, a technician who apparently wrote lots of complaints. He saw this as finally clearing out the difficult parts of Lebedev's legacy.
And that helped the atmosphere.
Significantly, he said. Anonymous complaints pretty much stopped for a long time after that. And once Didenko left, Amisov's biological cybernetics department was formally transferred into Glushkov's institute. They were already working closely anyway. Glushkov's workshops had built the USSR's first heart-lung machine for Amisov's surgeries, artificial valves, even a pressure chamber.
It sounds like the Institute was constantly evolving structurally, growing to match its ambitions.
It really was. It kept expanding. The SDB, the Special Design Bureau, formed in 63. Then in the early 80s, the Software Design Bureau split off from the SDB. The SDB itself became the Central Design Bureau, overseeing several independent design bureaus within it.
Like a tree branching out.
Exactly. And they formed these large sectors, bigger than typical departments for economic, biological, and medical cybernetics, covering the whole spectrum.
Beyond the machines and structures, Glushkov clearly saw people talent as absolutely core. His focus on personnel, especially training, was even mentioned when the Institute got the Order of Lenin in 69, right? The decree specifically said, and for training personnel.
That's right. It was central to his mission.
How did they approach this comprehensive training? It seems like it was on multiple levels.
He was absolutely multi-pronged. For existing staff, regular scientific seminars, lectures, especially as his machine design theory developed, helping them move from just intuition to understanding the logical structure.
Okay, upskilling the current team. What about new blood?
For university students, they set up specializations in computational math and computer science at Kiev State University and Kiev Polytechnic. Glushkov insisted his top people lecture and work directly with students. He even got special permission from the party's science department for PhD equivalence candidates to teach, ensuring direct influence.
And actively finding talent, not just waiting for graduates.
Incredibly proactive talent scouting. If employees were on business trips near universities with relevant programs, then you have lectures, consultations, and actively identify promising students even third or fourth years for recruitment.
Wow, embedding recruitment into travel. What about even younger? School kids.
Yep, even school children. The Institute patronized high schools, started teaching programming, ran contests and Olympiads right there at the Institute. They launched the Small Academy of Sciences in Crimea, where kids heard lectures from absolute top specialists like Lyapunov and Kolmogorov.
Incredible access for kids.
They even set up a dedicated boarding school in Theophania, initially just focused on cybernetics.
So, a complete pipeline from school right through to postgraduate work. How did they handle training for the engineers and technicians already working out in industry?
For them, they set up lectures at the House of Scientific and Technical Propaganda for retraining across Ukraine. They got strong support from the Komsomol Youth League, which organized cybernetic schools in major cities. This actually led to published lecture series on automata and algorithms.
Spreading the knowledge wide.
They also focused on the middling, the technicians and machine operators, proposed converting a technical school for this. And crucially, they laid the groundwork for the Kharkiv Institute of Radio Electronics, KRRE, building a solid base for both developers and users across Ukraine.
Now, a critical challenge you mentioned was attracting doctors of science, that higher postdoc degree. There weren't many around initially. How did Glushkov tackle that talent gap?
He actively worked to lure top candidates of science, the PhD equivalents from other places, like V.S. Mikhailovich, who he got from the Institute of Mathematics after, quote, a big fight with Gendenko. Also, E.L. Yushchenko, Y.V. Blagovechensky.
How did he convince them?
He famously persuaded Mikhailovich that his academic career would advance much faster with Glushkov's team. And he was right. He also actively scouted in other cities, found people like V.A. Kovalevsky and V.I. Skurikin.
What was his core philosophy when picking people? Was it just about qualifications?
Not entirely. Glushkov prioritized enthusiasm and potential. Crucially, also a non-quarrelsome character and the ability to work in a team. Strict specialty alignment wasn't the top factor. He believed loners couldn't build the complex systems they were aiming for.
Team players over brilliant jerks,
Yeah.
essentially.
Pretty much. He also tried hard to match research topics to people's interests, helping them get up to speed faster and potentially defend their doctoral theses on that work. This whole doctrine paid off massively. By 1982, the Institute had 60 doctors of science.
60. That's incredible growth.
It really is. He contrasted their success with other big Soviet science institutes. Said while others had more resources and could just recruit established doctors, his institute achieved harder 180-degree turn requalifications, like Skurikin moving from electric machines to systems engineering. His personal touch in recruiting rarely failed. People tended to stay and be effective long term.
Shifting now to his visions for the future, he prioritized developing the theory of computing machines' formal design, moving from automata theory to algebra of algorithms' data structures.
Right, he wasn't just building things, he was building the science behind them.
And he even challenged the dominant von Neumann architecture, didn't he? The standard sequential processing model. He saw microelectronics coming and thought it was, well, unhelpful.
Exactly. His goal was to simplify programming by bringing machine language closer to the actual input language people used. It was a radical idea he implemented in the MR series computers, despite getting criticism from giants like S.A. Lebedev.
Why push against the standard?
He believed that while humans provide the big architectural ideas, you needed machine systems, formal methods to refine them, optimize them, overcome difficulties in ways you just couldn't do manually.
He also pioneered something we now call application packages. Tell us about that. What was the idea?
Glushkov proposed specialized programming programs. That's exactly what we now call application packages.
Oh,
Basically, reusable blocks of code for groups of related tasks.
which seems obvious now, but back then.
But back then, the big focus was on creating universal programming languages. So his idea of specialized packages was seen as untimely by many, too niche maybe.
But his team pursued it.
Oh, yes. E.L. Yushchenko and V.L. Korlyuk from his seminar created the address programming language. Notably, they formulated the concept of address mapping for the first time ever. Glushkov himself was deep in developing algorithmic languages, like the analytic language for the MIR2 machine. His project system even aimed to synthesize design and programming, treating machines as software-hardware combos, where software could be auto-rewritten for new hardware.
Very forward thinking. And in artificial intelligence, he was way ahead of the curve, too. What were his main AI priorities?
He really focused on automating mathematical reasoning, specifically automating proofs, and as a first step, complex algebraic calculations. This led directly to the MIR2 machine.
The one you mentioned earlier.
Yeah, the one that implemented what he called primitive artificial intelligence. It could crack really complex integrals, find tricky substitutions that he said not every lecturer in the mathematics department could take on.
So, practical AI for mathematicians. What about broader AI?
The ultimate goal was natural language communication with machines. That required automating logical reasoning. But Glushkov found classical mathematical logic wasn't great for automation. Too abstract, maybe. So he spearheaded the development of practical mathematical logic, which he saw as the core direction.
And machine perception, vision, hearing.
Absolutely key. For vision, he actively recruited V.A. Kovalevsky from Kharkiv to work on image recognition. One practical early output was an automatic machine that could read typed letters and numbers produced in a small series.
Like early OCR.
Exactly. Kovalevsky later worked on speech recognition too, with T.K. Vinsuk. There was a missed opportunity, though, in robotics.
Oh, what happened there?
Glushkov set the task back in 1959, even before robots was a common term, to create an automatic robotic hand for a cart. But he couldn't find the right person for the mechanical side. It just didn't get done then. He really regretted it, said they could have had a robot hand by 1963, been the first in the world. His deputy, V. Ryback, picked up that work much later.
It sounds like he had this incredibly comprehensive vision, pulling all these threads, reasoning, perception, robotics together.
He absolutely did. The grand vision was synthesizing all these lines into manipulative robots with hands and vision and automating reasoning using natural language. And here's another stunner, semantic networks.
Right, you mentioned this earlier. What was the breakthrough?
In 1962, his team, Stogny, Ledichevsky, started working on recognizing the meaning of Russian phrases. They developed these semantic networks. Their algorithm could build a network from input sentences, figure out word relationships, even build a rudimentary model of the world.
Like understanding context.
Exactly. It could identify the chair stands on the ceiling as semantically false, even though it's grammatically perfect. It understood the implied meaning or world knowledge.
That concept, semantic networks, in 1962, that sounds incredibly modern. How is this received globally?
It caused a sensation at the big IFIP Congress in Munich that year. Apparently, the Americans had nothing like it. It led directly to Glushkov being elected to the IFIP program committee.
Wow, what happened to that research?
Sadly, he said it later withered away due to lack of people and time. But it just shows his extraordinary foresight. On process control, Glushkov had a clear philosophy. His institute shouldn't try to automate every single factory process.
Leave that to others.
Yeah, leave the routine stuff to the automation institutes. His role was to provide the universal control machines, the textbooks, the design principles, and personally lead the really complex, groundbreaking system implementations to keep the fundamental work grounded in practice.
Okay.
Later, when the Ministry of Instrumentation adopted more generic mini computers, which Glushkov felt were less suited for control, not Hewlett Packard, as he put it, his institute, lacking that direct industry support for the Dnipro style machines, shifted focus. They concentrated on the theory of process control and automating only really complex, selective technologies.
And in 1970, he introduced another fundamentally new idea, the software and hardware complex. What exactly did he mean by that?
This was revolutionary. He proposed designing integrated systems, software and hardware together, oriented toward specific classes of applications, moving beyond purely universal machines.
So tailored systems, but mass producible for a whole category.
Exactly. Like information processing systems would need data prep devices, maybe displays, but not necessarily the industrial RTUs that Dnipro had.
Yeah.
Different complexes for different jobs.
How did that go down?
Predictably, hostile reaction at first. The usual objection: Americans do not have such a concept.
So how did he get around that?
His solution was brilliant, almost sneaky. He approached a Swedish computer firm, advised them to adopt his concept, buy components from various Western companies, maybe a Hewlett Packard machine, memory from someone else, disks from another, assemble them, add Soviet software.
And sell it back to the USSR.
Exactly. Sell it as a new product, not just resale. This re-imported his own concept, caused a stir back home, and eventually led to its adoption within the CMEA, the Soviet Bloc's Economic Council. Though he felt they split it into too many narrow classes later on.
That's a masterclass in strategic maneuvering to overcome bureaucratic resistance. What about automating scientific research itself?
Initially, the focus was just processing experimental results. In the early 60s, they were processing data remotely from buoys in the Atlantic using the Kiev machine. He pointed out they did this before the Americans developed their CANAC standard for lab automation.
Ahead again.
Yeah, Dnipro's RTU was 61, TAMAC was 67, though, ironically, later Soviet engineers were forced to copy CAMAC due to policy decisions. Anyway, Glushkov industrially produced specialized setups for things like X-ray crystallography or mass spectrometry, moving from one-off custom builds to factory production.
Standardized labs in a box, almost.
Kinda, yeah. He also pushed for distributed systems, microcomputers right in the instruments, local mini-computers, linked to large central computers like the BESM-6 when needed, maybe via radio for big experiments like nuclear physics, and even automating the setup of experiments using robots because manual tuning of complex setups took way too long.
For computer-aided design, CAD, his institute focused specifically on automating computer design itself. But for other fields like construction or mechanical engineering,
There, they developed broader software and hardware complexes and integrated projects. They built two big systems, one for construction designers in Kiev that automatically generated drawings and documents,
that's huge.
and a classified system for mechanical engineering in Leningrad. Their work on automating the testing of complex objects also really impressed people, like a 1200 channel system for shipbuilders, far more complex than competing systems shown to top officials.
What was the ultimate goal for CAD in his view?
An automated system for, get this, whole science and technology development. Computers would independently run experiments, set up the gear, design prototypes, process results, build things, test them, and even generate the underlying theories.
Hugely ambitious.
Absolutely. He also ensured the Institute covered key mathematical methods, optimization, discrete math, mathematical physics, algebraic transformations, the tools needed for all this.
He also claimed his team was the first in the world to really articulate the idea of computer networks, doing remote transmissions back in the early 60s. Can you elaborate on that? Did they build a network?
Yes. He claimed they developed the first sketch project for a computer network between 1962 and 1964. It was for A.N. Kosygin, the chairman of the Council of Ministers. The idea was there, though it wasn't fully implemented then.
What was the focus?
Distributed data banks, specifically for OGAS, that was his grand, ultimately unrealized, vision for a nationwide computing network for economic management. A national digital nervous system, decades before the internet as we know it. He knew it was an enormous task needing a huge integrated program.
What about managing businesses or enterprises? ICS systems.
Right, Integrated Control Systems, or ICS. Work started in 1962. The goal was to create standard management systems, especially for industries like machine building. This required a lot more R&D than just automating a single process because you needed functional redundancy, adaptability, and parametric programs you could tweak for similar factories.
He also proposed a specialized operating system for these ICS back in 65, different from the standard batch systems.
Yeah, designed specifically for the regular scheduled flow of tasks you get in management, unlike the big batch processing OSs like IBM's OS 360 popular then. Later in the late 70s, they developed complex ICS, integrating CAD, process control, test automation, and organizational management altogether. The first was for a big new aircraft plant in Ulyanovsk.
Did these systems get widely used?
The earlier Lviv and Konsevo systems from the late 60s, early 70s were designed to cover pretty much everything in machine building. Orders went out for 600 systems based on the Konsevo model, though how consistently ministries actually implemented this typing policy varied a lot. They also had a separate line of research on modeling large systems using specialized languages like slang and NIDIS.
Looking at Glushkov himself, his impact, his recognition, his rise through the academic and political ranks was incredibly fast.
Meteoric is the word. Corresponding member of the Ukrainian Academy in 58, full academician there in 61, then academician of the main USSR Academy of Sciences in 64 in mathematics, including computational mathematics.
And that election was unusual.
Very. It apparently involved top figures like Keldysh, Payton, and Podgorny pulling strings to create an extra vacancy, allowing both Glushkov and another prominent mathematician, Linux, to get elected. Linux, by the way, reportedly intended to nominate Glushkov for the Nobel Prize in Economics before his own sudden death.
Wow. And he held political positions too.
Significant ones. Member of the Central Committee of the Communist Party of Ukraine from 64, deputy in the Ukrainian Supreme Soviet from 66, and the main USSR Supreme Soviet from 70. He was also vice president of the Ukrainian Academy from 62, though he apparently turned down the first VP job to stay closer to his scientific work.
His leadership roles seem endless. Chairman of countless scientific councils, cybernetics, computer science, bionics, system analysis, design automation.
He was everywhere. Editor-in-chief of key journals like Cybernetics on international editorial boards. Headed departments at top universities in Moscow and Kyiv. Scientific director of the Institute of National Economy Management in Moscow. The list goes on.
And the awards poured in. The Lenin Prize in 64 for automata theory.
3 orders of Lenin, including becoming a hero of socialist labor in 69. Multiple USSR state prizes for the MIR machines and design theory. Ukrainian state prizes for the Lviv ICS and top secret work. Council of Ministers Award. Krylov prizes. Lebedev Prize. Over 20 inventions officially credited. 7 gold medals from the VDNKH exhibition. It's quite a haul.
And internationally, he wasn't just a big name within the Soviet sphere, was he?
Absolutely not. He was like a foreign member of really prestigious academies. Germany's Leopoldina, that's the Academy of Planck and Einstein, plus the Bulgarian and Polish Academies of Sciences. He got top state honors from Bulgaria and East Germany for his work helping them with automation, honorary doctorate from Dresden Technical University. He was a key figure in IFIP, the International Information Processing Federation.
So his reputation was global.
Definitely. Glushkov mentions that by 1961, the success of his institute was so widely known that the whole union started talking about it. You'd hear about it in academic hotels way out in Siberia.
So we've navigated this profound legacy of Viktor Glushkov, a visionary whose final reflections, recorded in those last days, gave us this unique window into a life dedicated to turning intuition into, well, rigorous science.
Yeah, you've heard about his foundational management principles, that unity of theory and practice, decentralized responsibility ideas that really shaped a highly effective organization.
And his relentless pursuit of automation, his incredible foresight on AI, those semantic networks back in 62, problem-oriented labs.
You've seen how his strategic genius led to rapid innovations like the Dnipro machine, how he literally created a market before the product was even finished, and how he tirelessly built institutions and trained thousands, really shaping the whole landscape of computing over there.
He didn't just battle his illness, he battled skepticism, bureaucracy, constantly pushing boundaries. It's a scientific legacy that feels much bigger than just one person.
It absolutely is.
Yeah.
That depth of foresight, especially things like semantic networks, decades before modern AI really took off, it's genuinely astounding. Makes you wonder what else he saw coming that maybe didn't get fully realized.
It really does. Which brings us to a final thought for you, the listener. What enduring lessons can Glushkov's unwavering commitment to transforming abstract theory into practical application, his strategic vision for breaking down huge goals into achievable, self-sufficient stages, and his clear emphasis on nurturing enthusiasm and teamwork, what can all that offer us today as we face our own complex challenges in technological innovation and organizational leadership?
Whoops, I let it go too far. Well, how'd it go? I guess we can ask some questions.
Imagine a brilliant mind facing the end of their life, dedicating their final moments to distill decades of groundbreaking work into a. See, that's exactly where we're going today.
Yeah.
Oh, hey, I think our listeners got something to say.
Hi, so did he leave any specific instructions for future innovations or guidelines for people to follow?
That's a great question, and it's a very fitting one for what we're talking about.
Yeah, you're hitting on something central to these recordings.
He absolutely did leave specific instructions, not just for his family, but for the scientific community.
You could really call it his last will for science.
And that's exactly what many who knew him called it.
It wasn't just a personal memoir, but a clear articulation of future tasks.
Exactly. He laid out a roadmap, if you will, for what still needed to be developed.
Many of his ideas, we'll see, are still relevant today.
It was incredibly forward looking.
Okay, let's unpack this a bit more.
Quite a powerful image, isn't it?
This deep dive takes us into the extraordinary memoirs of Viktor Glushkov.
A truly pivotal figure in Soviet cybernetics and computing.
And our source material isn't, typical.
Not at all. It comes incredibly lucid voice made by his daughter, Olga.
This was during the last 9 days before he passed away in January 1982. Oh, yeah, let's hear it.
Hi, you mentioned his daughter. Does he have any progeny that went into cybernetics as well?
That's a fascinating question, and it speaks to the lasting impact Glushkov hoped to have.
You're right to pick up on the family connection since his daughter Olga was making these recordings.
While the source material doesn't explicitly state that his daughters went into cybernetics professionally, it highlights their crucial role in preserving his legacy.
His daughter Olga meticulously made these recordings, which is how we even have them.
And his other daughter, Vera, along with his granddaughter, Victoria, were instrumental in getting them translated and published.
So their contribution, while perhaps not directly in cybernetics research, was absolutely vital for the field.
It ensured that his last will for science, as we called it earlier, became accessible to a wider audience.
It's a different kind of legacy, an important one.
Yeah, without them, we wouldn't have this unparalleled lens into his mind.
January 1982.
They're a remarkably coherent and forward-looking summary of his segments.
His core conclusions and a detailed articulation tasks.
Recognizing their monumental significance gave them titles like The Last Deed of a Scientist or Those Who Stay.
Each title kind of captures his incredible effort to summarize a lifetime of work while battling a fatal illness.
His scientific life was, well, in many ways, a daily feat that went personal battle.
It was a collective action, really inspiring across the Soviet Union.
Absolutely.
Yep, go on.
So, did he mention any difficulties with the different bureaus and things like that that stopped his
That's a fantastic question, and it's a theme that absolutely runs through his memoirs.
You're jumping ahead to one of the most compelling aspects of his story.
He faced constant, intense battles with bureaucracy and
not just technical challenges, but political ones too.
Glushkov was very candid about these struggles.
In fact, his vision often faced hostility from various established groups,
including, at times, even those within his own scientific community.
He talks about getting decrees issued to overcome these obstacles.
And forming alliances with powerful political figures.
Sometimes, as you heard earlier with his daughters, it even involved family.
It's genuinely moving to consider that these lucid insights came from his final days.
Can you about the specific circumstances of these recordings?
What makes them such a rare
So, as you said, these voice recordings were made in a hospital too.
Specifically during those last 9 days.
His daughter, Olga, meticulously made them.
Right.
And we really owe a debt of gratitude to his other daughter, Vera, and Gloria, for allowing their translation and publication.
Because while parts of these memoirs were published before in Russian,
Okay.
Boris Malinovsky's History of Computing Technologies and Personalities, this particular transcribed work is in English for the very first time.
So this gives you an into the mind of a scientist reflecting on his life's work.
Looking to the future, knowing his time was short.
Exactly. It's unique.
To really grasp, go for it.
So did he mention anything about wishing to take a different direction or wishing he had tried something differently?
That's a profoundly insightful question, and it gets right to the heart of what makes these memoirs compelling.
You're touching on his self-reflection, especially knowing his time was limited.
He absolutely did. While he spoke with immense pride about his team's achievements,
He was also remarkably candid about missed opportunities and things he wished had gone differently.
one clear example comes up later in the area of robotics.
He recounts how he set the tax for an automatic robotic hand back in 1959.
Even before the term robot was widespread,
But he lamented that he couldn't find the right person.
someone with the mechanical aptitude, the willingness to work with their hands on that specific problem.
He genuinely regretted that they couldn't
He even said they could have had a working robotic hand by 1963.
which would have made them the first in the world to do so.
So yes, there were definitely moments of looking back and wishing for a different path.
Another area, which we'll also dive into, was semantic networks.
His team developed these groundbreaking networks in 1960,
Caused a sensation,
but he later expressed regret that this research withered away.
due to a lack of people and his own inability to dedicate enough time to its algorithmic work.
So he accomplished, but what he undone.
This highlights the incredible pressure and resource constraints he offered.
Despite all his successes and fighting through bureaucracy, some things just didn't get the traction he hoped.
Of what makes his stories so human and relatable.
Even a visionary has unfulfilled aspirations.
Now, to really grasp Kov's vision, we have to go back to the beginning.
How did he lay the groundwork for this scientific empire?
What was the initial landscape like when he arrived in Kiev?
Okay, so we begin in
Glushkov took a year-long sabbatical. Hey, yeah, what's up?
Sorry to jump the story a little bit, but he started the Institute of Cybernetics. What's the condition of it now?
That's a great question, and it's totally understandable to want to know about the current state of such an important institution.
Yeah, you're not jumping too far at all. It directly relates to his lasting legacy.
The Institute of Cybernetics, which Glushkov was so instrumental in forming and building, continues to be a very active and significant research center.
It's now officially known as the V.M. Glushkov Institute of Cybernetics of the National Academy of Sciences of Ukraine.
So his name is right there, honoring his profound contributions.
It's still a leading institution in information technology, computer science, and systems analysis.
They conduct research in fields like artificial intelligence, which he championed.
Control systems, even things like mathematical modeling, which were all core to his initial vision.
So it's not just a historical footnote, it's a living, evolving entity.
A direct continuation of the foundation he made, adapting and pushing boundaries.
Exactly. How robust and forward-thinking his initial organizational principles were.
Like the unity of theory and practice.
And that focus on long-range goals with short-range achievable.
Principles are still at play today in institutions.
What's thriving, carrying on the work he started?
From the Forest Engineering Institute in Sverdlov.
Complete his doctorate at City, which he successfully defended in December 55.
Right.
During this time, oh yeah, go on.
Did he talk about anything that wasn't understandable at the time that could be understood now? Like some kind of cryptic messages?
That is such a perceptive question, and it really gets to the essence of his extraordinary foresight.
You're absolutely right to pick up on that. He had many ideas that were truly ahead of their time.
Things that to his contemporaries might have seemed, well, almost cryptic, as you put it.
But which we can now fully understand and appreciate the genius of.
He talks about his early work on application packages.
What we call reusable software components today.
Back then, everyone was focused on universal programming languages.
His idea of specialized modular code was seen as untimely or too niche.
But it's now a fundamental part of software development.
Another fantastic example, which we touched on, is his work on semantic networks in 1962.
That's understanding the meaning of language, not just grammar.
His algorithms that could build networks from sentences.
Figure out how words relate
and even deduced if a grammatically correct sentence was some.
Like the chair stands on the ceiling.
Exactly. This was way before modern AI and natural language processing truly took off.
He even said at the time that Americans had nothing like it.
So his peers might have seen it as abstract.
But he was laying the groundwork for how computing human language.
It's a perfect example of what you're asking about,
Concepts that were on the fringe then.
but are central now.
He also had a vision for what he called software and hardware in 1970.
Integrated systems of software and hardware designed for specific classes.
People resisted it, saying Americans don't have
But this is exactly how computing often works.
tailored systems for different tasks.
So yes, his memoirs are full of these insights.
Ideas that were indeed understandable only much later,
They weren't cryptic. He saw the path.
just for everyone
It's
else.
time he met academician Enko
Who was then a key figure in the Ukrainian Academy.
and was pivotal.
Why pivotal?
Because in 1955, a decision to establish these prestigious academic computing centers in republics.
Including Ukraine.
And Didenko was tasked with this enormous undertaking.
Okay, so Yanenko had the job, but what about the resources?
Starting something like that from scratch sounds incredibly challenging.
Sparse would be an understatement, seriously.
They transferred equipment from the former Lebedev laboratory.
Ah, the MSM guys.
Yeah, the small electronic calculating machine, one of the earliest Soviet computers.
But the lab they inherited consisted of like at most 40 people.
Wow.
Only 4 candidates of sciences. That's kind of like a PhD in the West.
No full doctors of science, which is a higher degree, and hardly any young specialists.
So a tiny team.
Very. When Glushkov visited Kiev in March 1956 to pick personnel, he famously insisted on A.A. Litichevsky,
Even though Nadenko had reservations.
and that paid off.
Oh, brilliant. Many of these early recruits became leading employees at the Institute.
Litichevsky was crucial.
So, with such limited resources and a small team, what were the immediate challenges?
The first project.
And how did Glushkov's unique approach start showing up right away?
Well, the lab initially focused on 4 topics.
Machine for linear equations, the Kiev universal machine, and 2 secret projects. But Glushkov, right from the outset, was driven to industrialize production.
So he immediately went looking for external financing.
Smart. Outside the academy.
Exactly. He secured Dugna, the Joint Institute for Nuclear Research, as a customer for a second Kiev machine.
This was a masterstroke.
Why was that so important?
It resolved critical financing and supply issues that the Academy of Sciences just couldn't handle on its own.
Nadenko, to his credit, organized Glushkov's work well.
Gave him 3 days a week just to study the subject and get onboarded.
Okay, gave him some breathing room.
Yeah, well, a temporary supervisor covered his duties.
Nadenko,
Oh, go for it.
So you mentioned secret projects as a subdivision. What did that entail? Is there any information?
that's a great question. And it's a perfect example of the challenges and realities of working in that era.
You're right to pick up on that. It's definitely intriguing.
Glushkov's memoirs confirm that 2 of the 4 initial topics in the lab had secrecy levels.
Unfortunately, he doesn't elaborate on the specific nature of these projects.
He was pretty tight-lipped about the details, likely due to the ongoing classified nature of the work.
It's a common thread in a lot of Soviet-era scientific documentation.
What's fascinating here is that even with these secret projects ongoing, Glushkov was simultaneously pushing for open industrial applications,
It shows his strategic thinking.
balancing the with his drive for widespread adoption and practical use,
It highlights the dual nature of scientific development during the Cold War.
where class often ran parallel to more public innovation.
No specific details on those secret projects from him,
But the very existence of them hints at the broader scope of their early work.
and the very demands placed on his team.
Yeah, while a temporary supervisor duties.
Didenko also Korluk and Ilyushenko boosted edits of sciences to 6.
So small steps, but crucial ones.
It sounds like he wasn't just building a lab, but a whole ecosystem, really.
What about the physical space for all this?
Indeed. The computing center Kitayaskaya Street was under construction.
Initially, it was planned for just 3 machines.
3 large halls, which are at much bigger plans.
Foresight, even in the architecture.
Right. The initial estimate of 400 workstations was
It was a personal breakthrough for Glushkov.
he realized computer designs were based purely on engineering intuition.
Just kind of winging it,
Pretty much. He actually figured out how the MESM worked entirely on his own.
which, given the lack of documentation, was a huge undertaking. And from this, he declared his big decision.
And from science.
He set up a seminar where they rigorously analyzed how they were made.
Developed formal theory.
So straight was guesswork.
Exactly. He said they could immediately see what works and what doesn't.
Interestingly, he found Klein's automaton concept more elegant and logically clear than Turing's.
Which he felt was unnecessarily complicated for their practical.
That's a huge mindset shift, moving from intuition to association.
And it obviously paid off.
It did. On December 15, 1957, the Computing Center of the Academy of Sciences of the Ukrainian Republic was formally established.
About 120 employees and postgrads by then.
Including his first postgraduates, you mentioned.
Yes, A. Stogmy and VP Durka.
Oh, yeah, let's hear it.
So you mentioned he favored one type of
Oh,
design.
welcome. It's great to have you jump in.
We love hearing from you. What's on your mind?
You just said here. Are you talking about the location of the institute?
Or perhaps about where Glushkov was physically at that moment?
The source material is quite specific about the location of the institute.
And we were just about to talk about some of the first key individuals involved.
So to confirm, yeah,
Hi, so yeah, there was some kind of transmission issue. So you mentioned something about the Turing model or a different model. What were the differences?
Thank you for clarifying. We had a bit of a signal issue there.
no worries at all. Glad you brought that up again. It's a really important distinction.
You're referring to the Gluskov's preference for Klein's automaton concept over Turing's for their practical machine design.
Yeah, he explicitly called Turing's article, translated into Russian, unnecessarily complicated.
What Glushkov found more appealing about Klein's automaton was its algebraic, logically clear concept.
So instead of abstract, complex, theoretical constructs.
He preferred a framework that was directly applicable to building real-life machines.
His focus was turning from an art into a science.
And that meant a theory that you see what works and what doesn't.
Turing's model, while foundational to theoretical,
Was perhaps too abstract for the immediate hands-on challenges Glushkov's team faced.
they were designing the Kiev machine at the same seminar on this theory.
But for that, practicality and clarity were paramount for immediate application.
It's all about that unity of theory and practice we'll talk about shortly.
And this choice, this preference for Klein's approach, paid off for their design goals.
It allowed them to build a robust theoretical base, direct practical outcomes.
Does that have a little more sense now?
We can dive deeper if you like.
Otherwise, we can continue with the establishment of the
It was, as we mentioned, in Kiev.
Oh, yeah. Uh-huh.
Oh, Hagen. So yeah, what were the repercussions of adopting the clean method?
Follow-up, and you're getting right to the political heart of the story.
You're asking about the repercussions of those battles and the constant pushback he faced.
You're thinking about those hostilities from established groups we mentioned earlier, right?
Exactly. The source material reveals that these tensions had significant consequences, both positive and negative.
On the one hand, it meant constant bureaucratic struggle for his team.
He had to fight for recognition and against attempts to undermine his institute.
Like the campaign by Gnedenko and Shkabara to reclassify his institute as a mere calculating station.
That was a direct attack, as we discussed.
But the repercussions weren't all negative.
These battles, in a way, solidified Glushkov's resolve and
It forced him to build strong political alliances and secure top-level decrees to protect his work.
It also highlighted the necessity of recruiting the absolute best talent and where
Like getting control building for his staff.
unheard of move, directly addressing a common problem
So the repercussions were both the immense friction he experienced.
and the strategic adaptations he made to overcome it, ultimately strengthening his vision.
Did that kind of repercussion make sense?
We can dive deeper if you like.
Otherwise, we can continue.
Hi, thanks for the explanations. I was asking about the repercussions of taking the
You're looking for more details on those repercussions. Absolutely.
You're honing in on a critical part of Glushkov's journey.
Beyond the strategic adaptations we just touched on, these battles also had a very personal toll, actually.
Glushkov talks about the hard feelings that emerge from these disputes.
Especially regarding the competition for specialists and the division of property.
He mentions how Shkabara, as we discussed, played a nasty role in inflaming passions.
So it wasn't just abstract, it created real and tension.
This friction even led to key figures like Gnedenko, eventually leaving Kiev.
Which while perhaps a strategic win for many of some early collaborators,
So the reshaping of the scientific landscape around him.
leading to personnel changes, though sometimes contentious definition of roles,
It definitely wasn't smooth.
and the immense resilience Glushkov needed to push his vision forward.
Despite all the pushback and internal strife.
Does that give you a fuller picture of the repercussions?
We can certainly continue as we move through his career.
And as we mentioned today, though much expanded.
It truly was Glushkov's base of operations.
So to confirm the location, that's where it was.
And we can continue with the people he brought in.
Glushkov's first postgraduates, A.A. Stogny and Vepi Durkach, were crucial.
He chose the academy over partly because of an uninspiring chat with the dean at Kyiv University.
His appointment needed approval from Gian Savin, the vice president.
And Savin had doubts.
He doubted Glushkov could manage hundreds, given his smaller department back in the Urals.
But the United Party Committee and the Science Department of the Central Committee massive help.
Construction, hiring, even getting residence permits.
Social support, helping to counteract those bureaucratic repercussions.
Okay, so from these formative years, Glushkov developed these key organizational principles for teams, right?
Which he credited with their success, despite the challenges.
He did. He consistently applied them.
One of his core beliefs was the unity of theory and practice.
Now, this principle wasn't new, but Glushkov profoundly refined it.
How so?
He stated that science, especially young science, should not do practical applications.
Fair enough.
Okay.
But here's the crucial addition.
One should not work, no matter how important it may seem, if it is not preceded by theoretical comprehension.
So theory first, always. That's the subtle but profound shift.
Why?
Because it forced a fundamental rethink. Instead of just building one-off custom solutions, he had to build a theoretical base.
He ensured incredible versatility.
His words, potentially covering 500 applications instead of one.
Wow. Example?
Sure. Instead of developing custom solutions for 8 specific customer orders for modeling discrete systems.
Glushkov told T.P. Marjanovich's team.
No, create Slung, language for modeling these systems.
A platform approach.
Then he educated the customers, showed them how this universal solution met their real needs better.
It allowed for broad fundamental research with massive potential.
A masterclass in foresight and scale, aim for today.
So build foundation, not just solve immediate problems.
What other core principles did he apply?
Another key one was the unity of long-range and short-range goals.
This dictates that one should not undertake any small individual works if one cannot evaluation of these works in the future.
Don't start dead-end projects.
Right, and conversely, long-term research should only be undertaken if it can be broken down into stages, with each step promising a self-sufficient science and practical significance.
That's incredibly strategic, especially for something as complex as computer science.
Break it down into achievable, useful.
Precisely.
Approach apply to something like AI or robotics?
Absolutely. This staged his whole intellectualization of machines
led to the MIR1 and MIR2 machines, and then the future work on automating proof.
Earlier, his regret about the robotic hand, and this staged approach was meant to prevent issues.
Solve vision and hearing, for instance, before getting bogged down in intricate.
He also championed decentralized responsibility.
What did that look like in practice, especially, in a top-down system like the Soviet Union?
Well, Glushkov advocated for clear areas of responsibility to managers and then minimizing direct interference.
Even if subordinates seemed to be doing things wrong.
Really? He wouldn't step in?
Not directly on the decision. Usually he'd focus on integral indicators, the overall outcomes.
There's a great example, apartment allegation. Contentious issue, right?
Always.
So when complaints arose, Mikhailovich's decisions on who got apartments, Glushkov refused to overturn.
If they were unfair,
It was fascinating.
he said a senior manager canceling a subordinate's hours of work in 5 minutes would fundamentally undermine their leadership.
No one would take responsibility seriously again.
Makes sense.
He used those complaints to identify root causes.
To address the overall style of work, the underlying and improve the system itself.
He was critical of hierarchies where middle managers bogged down, struggled to delegate.
Holding on to power, maybe.
Exactly. Issues like housing, often seen as a source of real power, were held onto tightly, hindering efficient management.
So rather than micromanage, back to our listener. What's up?
So he made multiple books
He focused on setting up effective systems.
You're agreeing with the approach he took, which is spot on.
It wasn't about the individual dispute as much as the systemic solution.
And he even formalized that for something like space distribution.
Yes, for that persistent issue, he developed a precise procedure.
Or manage the files and set the technical standards for space.
And priorities, like from socialistic competition results, automatically determine allocation.
Taking the personal bias out of it.
Right. And to monitor usage, he used probability theory and random sampling.
Commissions would randomly check rooms.
If you used your space poorly, you'd get less next time.
Clever. Accountability.
The core principle was a deputy director would appeal their decisions.
Or for poor personnel selection and training in their
For every specific slip up by a subordinate they couldn't directly control.
accountability at the right level.
Building on that idea of nurturing leadership, attracting the right talent, must have been critical, especially early on.
How did he manage that?
Talent was absolutely paramount, and they got a huge boost.
In an almost unheard of move, in unprecedented decision.
They let the institute control a residential building nearby.
Their own
Yeah, 113 Bolshaya Katevskaya Street.
This was practically unheard of.
Usually institutes got just a few flats per building.
It was a mass attracting and retaining top staff.
Despite the repercussions across the country earlier.
Okay, that makes sense. Which brings us to a truly remarkable story.
So did Victor Glushkov and his assistants live on site?
That's a very practical and insightful question, and it speaks to how dedicated these scientists were.
You're right to wonder about that, especially given the perks they were offering.
Glushkov himself lived in Kiev after March 1956.
Initially alone, and then his wife, Valentina Mikhailovna, joined him in August.
As for his assistants and other leading staff, the source explicitly states that the residential building in Bolshaya Street was entirely at the disposal of the Institute.
This allowed them to accommodate our leading staff.
So while it wasn't strictly on site in the same building as labs,
Essentially, their dedicated housing right nearby.
it was a crucial part of attracting, as we just discussed,
It meant they could live in close proximity to their work.
which would have fostered that intense collaborative environment Glushkov was building.
So yes, many of his key people would have lived there.
It was part of the whole ecosystem he was creating.
Does that answer your question about where they lived?
We can continue with some truly remarkable breakthroughs in machine development.
A truly remarkable Dnipro breakthrough between 1959 and 61.
What was the challenge they were trying to solve here?
Right. So the challenge back then was that traditional automation relied on analog devices.
You limited machines for the process.
And they're only really good for simple differential equations.
Very rigid.
So, which he presented at a big conference in Kiev in 1959.
Was to create a universal control machine.
And how was that received?
With hostility, apparently. Established automators, even from computing specialists.
They just imagined practically huge, unreliable lamp-based machines.
It was a bold, controversial idea.
So how did they overcome that skepticism and build something revolutionary?
Solution, the key, was B.N. Malinowski's early work on semiconductor elements in the USSR.
Crucial.
Glushkov's team just boldly pursued the project despite unanimous opposition.
Getsy, what were the core ideas for Dnipro?
They articulated foundational ideas that basically became industry standards later.
The machine had to be semiconductor based, obviously. Transportable.
Highly protected for rough industrial.
Bit, just 16-bit, which they figured was control processes.
Okay.
And crucially, a universal remote telecontrol unit, or RTU.
Think of it as a set of analog to digital and digital to analog converters.
The interface connecting the machine to the actual factory floor.
Malinowski was chief designer, Glushkov the scientific supervisor.
And they did this in just 2 years, June 59 to July 61.
Glushkov called it a world, especially since Ukraine wasn't supposed to be building computers.
How on earth did they manage that speed?
He was pure genius. He paralleled all the stages.
Development, training future user, and preparing production all at the same time.
Wow. Okay. How?
He immediately got powerful political figures and
Olga Vichenko, Evy Podgorny.
got decrees issued mandating the Kyiv radio primer plant to help develop and manufacture it.
And greenlighting the construction of the VOM plant, staff radio primer.
He built the factory while designing the machine.
Essentially, yes. And Glushkov personally lectured the radio primer design on machine design.
making sure they were totally aligned with the vision,
That's incredible foresight.
building the demand and the production capacity simultaneously.
What about testing and early applications? How did they prove it worked?
They picked 4 initial industrial sites.
A shipyard, a metallurgical plant, a chemical plant, a soda plant, later an ammonium nitrate plant too.
They got these places ready for computer control.
Okay.
The initial move RTU was intentionally designed assistant to the human operator, not a full replacement.
That was smart.
Acknowledge human factors and the high cost of errors, like steel freezing in a converter if the computer messed up.
And debugging.
They pioneered remote data from the mobile RTUs was sent via telegraph. Can you imagine?
Back to the Kyiv machine at the computing center.
Which was already running by then.
Right, since 58. This let them debug the software for the future DPro machine in parallel.
While also tackling the basic control algorithm challenges.
And the results, you mentioned they were
At the steel converter, they cut down those, reduced rejects, productivity by at least 10%.
and relatively simple algorithms and, frankly, imperfect sensors.
Wow. Even with basic tech, the impact was huge.
Soda output up 4%, metallurgy 10-12%. It was tangible.
They even set up competitions.
Plant directors watched the operator using the machine got much better results than their very best human dispatchers working alone.
That must have convinced them.
Absolutely. That's immediately made the plant directors demand more.
Glushkov. Oh yeah, let's hear it.
Is there anything in today's industry that resembles what you just mentioned?
Oh, that's a fantastic question, and it's a perfect way to connect Glushkov's pioneering work to today.
You're asking if those innovations, like the universal control machine and remote debugging, have modern parallels.
And the answer is absolutely, so many ways.
What Glushkov Dnipro, creating a universal control machine for various industrial processes, directly foreshadows what we now call industrial control systems, or ICS.
Think about SCADA systems, supervisory control, and data
Distributed control systems, DCS. These are the brains of modern factories, power grids, and even water treatment plants.
They're designed to control and monitor diverse industrial processes, exactly what the Dnipro aimed.
Universal remote telecontrol unit that we're connecting to the factory floor.
That's essentially the ancestor of modern industrial sensors and actuators.
It's the hardware that bridges the digital control system with the physical world.
Connecting the computer to, say, a valve or a temperature. And remote debugging, send machine.
That's now cloud-based industrial.
Data from machines is streamed to central for analysis and troubleshooting.
Or even
identifying issues before they cause downtime.
So while the technology looks core problems they were solving, solutions they devised, similar.
He was building the foundational concepts for today's automated industries.
Is how much he anticipated.
Now, going with that, Glushkov, ever the strategist, pointed them
straight to the radio primer plant, which was already gearing up for serial production.
He created the market even before the type was ready.
Amazing. And the production,
because DPro was developed between the Institute and the plant's engineers, no US versus them.
You save huge amounts of time, at least 2 development stages, because it was custom tech from the start.
Seamless integration, much like how modern industrial providers work with clients today.
Yeah. And the director of Radio Primer, Matvey Zinovich, took a massive.
He courageously started building 10 copies before the prototype even passed the tests. Hugely. But Dnipro passed tests perfectly.
In a dusty, hot, plus 50 degrees C.
And was rugged enough to be for military exerciser.
Compact, reliable, truly built for industry.
A triumph of engineering and strategy.
Well, machine development after.
Well, in 1961, they started on the MIR-1 machine.
The goal here was different. Unified elementary base, semiconductor elements for all their future mini machines.
Practice.
Standardizing components like common industrial modules today.
Exactly. This effort led to the formation of their own design bureau,
which in 1963 officially became the Special Design Bureau of Mathematical Machines and SDBMMS.
And these common elements they designed were so good decade across the Ministry of Instrumentation and Automation.
So they weren't just building machines, they were building the building blocks.
Did they catch up?
It was close. Glushkov noted that while America was working on similar multi-purpose control semiconductor machines earlier,
they
Fried. Yeah, it fried. So there's a satellite signal loss, and then it totally fries the whole configuration. So that's it for this. I mean, we got some good questions in. Until I fix that Starlink satellite and it doesn't have any bandwidth gaps, we're gonna have this issue. So I need to get out there and do that at some point. Hopefully, maybe tomorrow. Tomorrow is a holiday, um, so I don't have to work for someone else. Maybe work for myself. So I'll get that done. Okay, so this has been Military Industrial Museum. Please subscribe. Please check out my channel. Got a lot of AI based researches and music and little anime cartoons and stuff, and plus a lot of military subjects. Okay, thanks for joining me. I I have a little broadcast live stream every night at 9 p.m. Pacific Standard Time. Adieu.